Hi, I'm going to work out some of the problems from customized non-credit review for test 3. The first thing in this section, you must remember all the trig identities, especially the sum and difference, double angle, half angle, cofunction, and you do not need to remember the product to sum and sum to product. Those are the identities that will not be included in the test, so you can concentrate on the easier ones to remember. But you do need to write them down so that you do not make a mistake in the signs, and you must come up with your own way to remember. It can be a pattern you may want to find out. I may suggest some, but you can come up with your own pattern to remember the sum, difference, and double and half angle identities. So first thing, what I would suggest, you do not need to memorize every single identity. What you need to do is remember just one set of the sum or difference, doesn't matter which one. But if you just work on sum, then the difference will be just the opposite sign. It remains exact same format and everything, just that the sign will change. Just like if you notice here in my cosine A plus B, it is cosine A cosine B minus sine A sine B. Pay attention that when the sign was plus sign, on the right hand side you had your negative sign. Okay, so it's a subtraction formula. And when you try to change the cosine of A plus B to cosine of A minus B, the only change you will notice is in that sign, okay, on the right hand side. For sine function, if you write down the sine of A plus B, it is sine A cosine B plus cosine A sine B. It's pretty simple to remember. It maintains the sign as well as it is a combination of both sine and cosine function. You may also pay attention that cosine function was in pairs, cosine cosine sine sine, so that may be one of the ways you can remember that cosine function always comes in pairs and it has opposite sign. And for sine function, it comes in combination and it has the same sign. Tangent A plus B is also given. That's not too bad. Now for a double angle, what you need to do is basically just substitute A equals B angle and you have all the identities. Cosine 2A has three different forms. The very first one comes from that Pythagorean theorem, so it is cosine square A minus sine square A, and if you change everything in terms of cosine function or sine function, you get the other two forms. Okay, and sine 2A is 2 sine A cosine A. That's one of the simplest ones to remember. Tangent 2A has 2 tangent A 1 minus tan square A. Now for half angle, pay attention that if you remember one half angle, you know the other ones. For cosine A by 2, you always use the plus minus sign when you do not know the angle measurement, and but if you know it, then you have to choose the correct plus or minus sign to go along with it. And your sine A by 2 is the exact same format as the previous one, just that the sign will be negative this time. And tangent A by 2 is sine of A by 2 over cosine A over 2. So if you just divide those two, you definitely get this form. And there are two other forms, you may need to remember them as well. Okay, now let's get to actually work out some of the sum, difference, or double angle, half angle type problems. So to find out your cosine of negative 195 degrees, it is a good idea to take care of your negative angle first. Okay, and if you remember cosine function is an even function, so it will be cosine of negative 195. It is written as the same as cosine of 195, and cosine of 195 can be written as sum of two angle measurements, which is 135 and 60, and then you would expand it just like your cosine of a plus b form, and it will have the special angles from the unit circle, so you can substitute the values and simplify and get the answer. Okay, now for cosine of negative pi by 12, this particular problem, it's actually not bad. It looks sometimes, with the radian measurement, it's not easy to determine which are the two special angles you have to consider, but if you can change that radian measurement into degrees, it's much easier for you to comprehend what are the two special angles you would like to consider. So to show you, how easy it is to figure out from radian to degrees, is that you do pi over 6. You already know it's 30 degrees, so 1/2 of pi over 6 gives you pi over 12. So basically this is the relationship you may remember. And cosine of negative pi over 12 will be cosine of negative 15, and that is same as my cosine of 15 because that is an even function. Okay, and if I know cosine of 15 degrees, then all I need to come up with two special angles. It can be anything. You could have done cosine of 60 minus 45. That will still be absolutely correct answer. Okay, now another example very similar to the previous one. This one is cosine of 15 degrees cosine 75 minus sine 15 degrees sine 75 degrees, and if you pay attention, it is a pair in pairs, so it relates to your cosine function, and also pay attention that it is a negative sign, so it will be actually added at the sum of the two angles, so it will be basically cosine of 15 plus 75, which is cosine 90, and it becomes 0 then. Okay, similar example, it's cosine cosine sine sine, and this gives you a good practice of writing, just matching the identities. So basically, so far you have noticed, as long as you remember the identities, the problems are pretty simple. All you need to do is match the identity and you have your final answer. Okay, now take a look at this particular one, cotangent of 38 degrees, and it asks you to write down in terms of cofunction identity. If you remember the cofunction identity, it's basically sine function. If you just add a term co in front of it, you get that cofunction of that one, so it actually gives you cosine. Okay, and same way, secant, it relates to your cosecant function, and vice versa. So now your tangent goes to cotangent, right? So these two trigonometric functions, they are related with the complementary angles. So basically, if I know sine of 20 degrees, I also know that my cofunction will be cosine of 90 degrees minus the given angles, so it will be basically cosine of 70 degrees. Similarly, cotangent of 38 degrees will be same as my tangent of 90 minus 38, which turns out to be tangent of 52 degrees. Okay, so that's my final answer. Okay, a similar example. This one looks a little more complicated, but it's no different than the previous one. So you just write down cotangent of whatever that was, and on the right hand side, instead of tangent, I'll convert that to cotangent and I'll subtract it from 90 degrees. what my purpose is to write it down in such a way that it is cotangent A equals cotangent B, which will indicate that my angle A will be equals to angle B, and that's how I will solve my angle theta. Okay. The very next problem is sine of 105. So you just come up with two special angles and you utilize that trig identity sine of A plus B form and substitute and get the answer. Okay. The problems I have already worked out, so you should be able to follow them. You can pause and watch the steps. And the key idea for this type of problem, whenever it's the negative angle and in radian, you take care of that by converting that into degrees angle measurement and taking care of the negative angle first, and then come up with the two special angles. You can do the whole problem in terms of degrees and you'll still get the correct answer. Okay. Now this one is a very similar problem you used to do in an early stage. In tests 1 you had done something like this one, that if you knew one of the trigonometric functions and a specific quadrant, you can find out any of the trigonometric functions. So you would plot that triangle in the proper quadrant and label the two sides based on the ratio, and then you find the third side and you can find out any of the trigonometric functions from all three sides of the right triangle. Same exact idea here. It's given that the tangent it's given cosine S and sine of t, that is given actually. So these two are given information. Based on that, and S and T both are in quadrant 3, and you always make separate triangles to label the sides, and from that one you can find out your sine, cosine and tangent and utilize the identity how to expand, and you will have the final answer. Hope this helps.